All right, good morning, everybody, and welcome to the first session of the 60th Congress of the Grassland Society of Southern Africa. I think we're all super stoked to be here to celebrate this milestone with the Society. I'm Susie Vetter, I'm chairing this first session, and I'm going to avoid using up precious science time or science fiction time, and proceed to introducing our opening keynote speaker, Tim O'Connor, who needs no introduction. And I'm not making this up, he told me this himself. He said, please say, this is Tim O'Connor, and he's giving the keynote. I will add, though, that he then followed this by telling me he was a rock star in his previous life. And I think you will all agree that this thing about the previous life is false modesty, because he is one of the rock stars of grassland science, winner of the 2015 GSSA Prestige Award, and I will say nothing more but hand over to Tim.
Okay. Right, thank you, Susie, for those kind words, and thanks for this opportunity of sharing a few thoughts. This will be a talk of breadth rather than depth, reviewing a couple of issues which I think are worthy of a bit of consideration. So what's the Rocky Horror Show actually got to do with the GSSA? The most obvious, 60th anniversary, September this year, the Rocky Horror is its 50th. Just reflect that we're about a century into rangeland research in Southern Africa. I put it down to the 1920 Drought Commission as a turning point, but it goes deeper than that. If you're listening to the opening track from Science Fiction Double Feature, those are the movies that are actually mentioned, all produced between the 20s and the 60s, early 60s. And what actually is science fiction all about? Basically, if you want a cliche phrase, it's a never-ending fight of good versus evil. And the point is, they're using science in pursuit of it. And here's a simple link. I have presumed I'm speaking to an audience who engage in science basically to make the world a better place in terms of the discipline which they serve. So, as distinct from dealings, for example, with more academic audiences where one is trying to gain a depth of understanding. Obviously, they're not divorced. These are two sides of a similar calling, but by and large, we tend to work in the context of decision-making of real systems in real time. And I want to address two simple issues, and unfortunately, they will be shallowly addressed. Can we ensure sustainability of the society, and are our current approaches good enough? I'm going to look at the journal. I want to resurrect the systems approach and why it doesn't seem to have caught on. I want to look at then expanding to more complex objectives in management and introduce the ecosystem approach. And of that, I'll introduce the absolute importance of careful consideration of time and space as two critical dimensions that we need to confront. With thinking about the society, we could talk about its two key components. We haven't got time. The annual Congress is a simple cost benefit. You keep on coming when you feel the return's good enough. I think it's fair to say the journal has had some thin times in the history which I have known it. And we really, my belief is we have to ensure this journal persists. And therefore, how do we support a local journal? And I just want to look at a couple of things. So what do you actually look for when you publish? Now, I took, this is a sample size of one. I took 40 or so papers where I was first or second author in international versus local journals. It's obvious. If you want recognition, if this is a big deal to you, if you want to be cited, this is the number of citations per annum plotted against the year in which the paper was published. Go international. If getting your name out there is a big deal in your life, go international. But there are other things to consider. And what I have certainly encountered in my life is that I want to deal often with hard knowledge, especially when I'm reviewing, doing a broader review of a subject. You're there to get hard information. And to be blunt, I find international journals very lacking. They are geared towards having something to say about a contemporary paradigm, Whereas local journals, not only do they allow you more latitude with length, it often has more substantive information on the here and now of the particular systems in which you work. There are issues about review. Personally, I've never been convinced about double blind, but that's a discussion for another day. What I hope to illustrate, and it will be in a shallow manner, is that we have a relative dearth of basic knowledge on various features, and we need to increase the submission of papers about simple features. And that gets down to looking at the nature of our grassland science here. Now, this is hell of an opinionated. Anyone can reject it, obviously. But I find South African grassland science very empirical. It measures this against that and gets a story out of it. It doesn't, by and large, look at the big picture. There are obviously exceptions, and we'll touch on some of them. So it is not holistic, and it does not generally look at the larger system. It looks at questions within the system because it generates output and makes you look like you're getting somewhere. And it just occurs to me, you know, if hydrologists or meteorologists were to function like we do, we'd have absolutely no understanding about our water supplies and our climate. They look at the big picture, and they might not have started there and they had to work there, but I want to ask why we've had systems approach thinking around for over 50 years. Brian Walker was very instrumental in trying to promote it. And he has a very simple statement in one of these two papers. This is 50 years ago, a lot of anniversaries here. If the dynamics of an ecosystem are to be properly understood, sufficient to allow for manipulation with a confident prediction of the outcome, this is what management is. We manipulate. Then it is necessary to study the whole thing rather than this component eclectic approach we tend to take. So the key premise of a system approach is that you have often just one or a few functions. For example, in livestock production, you're looking at how to maximize or at least have stable livestock production and maintain the quality of your resource, a very simple objective. So you pursue a purpose, and I'll introduce this with two quick little examples. So the first is, and I'm not walking the talk in a big way. This is not being my own field of endeavor, but I want to speak to my own experiences, otherwise you get lost. We had a little exercise where I was motivated by the whole thing of bush encroachment. It's been part of my research thing. And I've often wondered, you know, we talk about this and that having an effect. Suddenly CO2 is the explanation of everything, but it's actually a little bit more complicated than that. And we asked the question, can Mopani worms actually influence the tree-grass balance of Mopani systems? And we set up a very simple consumer resource model, a bunch of differential equations, 5-state variables, Mopani biomass, grass biomass density, elephant grazer, and worm biomass density. And let's just go to the top two panels there. You will see that when you, in the bottom two panels, you manipulate through mortality rates, etc., the abundance of Mopani worm, you get a clear system response of under low Mopani, the trees flatten the grasses. Whereas when you increase Mopani worms, the grasses actually prevail at far more significant amounts. A theoretical knowledge model, but one with some insight into, shouldn't we be asking questions about the harvesting of Mopani worms, etc. But what I wanted to get back to the theme, in doing this, we thought it would be a cinch. We had 26 parameters to estimate. They're biomass related, and a lot of them relate to growth rates, etc. You can quickly skim that. And what was striking was the paucity in the literature of the sort of information we needed to extract. And almost ironically, Farmers Weekly gave us one of the most single important papers in terms of developing this model. It overall showed a very shallow knowledge of biomass dynamics. I enjoyed it because it does have some bearing on a long-standing management argument, and it does relate to decision-making in the real world about harvesting. A second one, the collapse of the Mapungubwe Society, which is where Botswana, Zim, and South Africa meet. I'm assuming most people have heard of it. It was at its peak in 1290 AD, but thereafter more or less collapsed very dramatically within the space of a decade or two. corresponding to a major decrease in mean annual rainfall, a mean of about 500 dropped by 100 to 150. That's dramatic. And we just simply wanted to ask the question, yes, cropping was a real sort of reason that society dropped, but did the sudden increase in aridity destabilize livestock production? We used Kuganor's savanna model, and we had 3 different scenarios by 2 different rainfall regimes. So we looked at livestock only, livestock in competition with wildlife, and wildlife only under a dry scenario on the left, which is what the system had become, versus the preceding system of the wet on the right. The top 2 panels, with no competition from wildlife, cattle persist. Yes, up and down, but they persist. But under the dry scenario, in competition with livestock, with wildlife, livestock eventually crashed to extinction. Now, in an era of climate change, obviously one can draw parallels that models of this have some sort of insight. Oh, there we are. Okay, the slide needs to come up though, yeah? Yeah, okay, so of relevance to this talk, yeah, why have we not progressed? I then introduced biodiversity through an exercise in which I was involved. Analytic hierarchy process was used to gauge the effect of different land uses on diversity with 46 indicators. A similar exercise in the, have we got this again? A similar exercise in this. The point is that there was very little hard science which entered into this exercise. That's not to say it's a bad product. Management products are using the information at hand to make the best decision you can. That's what a lot of people miss about the difference between management and science. I thought we did a reasonable job on that in terms of assisting KZN environment to make decisions about applications for development involving different land uses. But what came out of that was just the incredible dearth of knowledge on simple impacts such as grazing systems on biodiversity, etc. I then said we're going to use the ecosystem concept to look at biodiversity. I then wanted to introduce my little elephants. And this is what I think, this is lovely work done by Michelle Henley and colleagues. Elephants Alive, tracking elephants. And up at the top, I haven't got a pointer, top left is Gonorrhea, Kruger down the side, Limpopo next to it. In Mozambique, 2 big parks called Benini and Zinave. Elephants were eliminated from Mozambique plus minus, well, central Mozambique as a consequence of the civil war started 75, ended in the early 2000s. But just look at where the cows on the left, bulls on the right. I mean, the scale, and that's not hundreds of different bulls. That one trending far up into Benini and Zinave is just a couple of bulls. The point is the animals are operating at a spatial scale that far exceeds the size of the protected area when given the opportunity to do so. So when faced with what are elephants doing in Gonorrhea, one can do a number of exercises. Here's a first example. I'll flick through it quickly. That bit on the right-hand side, as you look at it, of the river between the road was fenced with an electric fence, 2012, a partially protected plot. Elephants get in there. Now, you can see the bank below. That should be a no-brainer that it's elephants. I mean, what else could you conclude? Let's just look at the results. Top left, canopy volume. If you can look at it, there's a floodplain and a terrace, but it should be obvious that everything between kind of 1 and up to 11 meters, certainly for the floodplain, has been totally compromised or eliminated or reduced rather by elephants. Bottom left, a corresponding inverse relationship with the amount of damage. Bottom right, there's Acacia xanthophylla. And by the way, The flora of Zimbabwe is the official naming for plants, and they did not recognize the name change for acacia. Yay for them. And you can just, a simple demonstration that lots of regeneration of acacia xanthophylla. So overall, an empirical picture for this little location that elephants have whacked the hell out of it. However, let's look closely. 1963-64, using bulldozers, they bulldozed the upper terrace. The 68 aerial photograph there, all that lightly shaded area on the bank of the river is one example of the extent of bulldozing. They left some large trees. 9 years later, if you look at that bank there, you'll see incredible amount of regrowth from root coppice, and you can see the graph that there was a strong trend in response. Nonetheless, they had affected this clearing had affected certainly the composition and biomass of the thing. Another event which happened. So Chipinda was always known for its reed beds there, extending into the distance. So this is repeat photography of one in 82. The 93, just to show that after the 91-92 drought, the most severe on record, the reed bed had shrunk, still there. Come 2024, as a consequence, starting with Cyclone Helene in February 2000, if you recall the TV footage, those of you old enough, of the Mozambican lady giving birth in the top of a thorn tree, rescued by a SADF helicopter. That was that flood. It was a monster. A visual account of trees getting plucked out. The concrete beams on the bridge, if you recall, let's just go back. Come on. Okay, it doesn't want to go back to the thing. Of the bridge were lifted off and carried down thing. However, it recovered from that, and by 2013, the graph on the bottom right, the reed beds had reached their zenith of cover, and they were heavily used by elephants after that. But it was Cyclone Dineo again in 2017, which stripped the entire reed bed, and I mean entire reed bed. You find a stalk, not a patch. And unfortunately, the reed beds are calculated at their zenith could support 11,500 elephant foraging days. That's more than enough to get the local population through the height of the dry season, September, October, which is when they're desperate for food. And the reed beds were lost as a prolonged drought, 17, 18, 18, 19, 19, 20, a really bad prolonged drought, during which elephants inevitably eat more woody stuff, and they nail the riverine. But the point is, it has to be seen in the context of the history of what had predisposed that system to such heavy use. You cannot ignore the effects of clearing for tsetse control, and you cannot ignore the effects of these incredible floods. And just to prolong the history, tsetse control, tsetse surfaced in this portion of Zimbabwe. It was being noticed in the 1950s, concern about the livestock industry, putting a whole suite of control measures. But why were tsetse re-advancing? They had been there previously and their range has shrunk. It is conjectured on account of the rinderpest pandemic during the 1890s. Remove the food source of the fly and you reduce the abundance of the fly. Their range had shrunk into small pockets, and as wildlife populations recovered, so it was expanding. So we have a sort of, let's call it 130-year narrative where we have to consider history in terms of understanding the present. And I just look at a lot of stuff that comes out, all this, you get some quite erudite papers that couch themselves in theoretical terms and ignore history. But you're dealing with major components such as leadwoods, live in the order of 800 years. Baobabs live in the order of 1,000 to 2,000 years. The biota supported by that system have been dramatically affected by history, and therefore, I think it's not a great premise in which to assume. A quick second example, Riverine Mopani. What I'm trying to show is that at different locations, the spatio-temporal pattern of response to elephant impact is differ. Now, Mopani, the quick story, they whack all the trees up to about 8 meters. In the background there, you'll see this hedged effect. That hedged effect produces a phenomenal amount of forage for elephants. and you are not diminishing the amount of actual Mopani individuals. The ones they can't break down, stems too big, middle panel on the right, remain as emergents. Those are really important for biodiversity. They provide, Mopani stems have lovely cavities. You've got a whole lot of stem nesting jobs, you know, racket-tailed rollers, scimitar-billed hoopoes, a whole bunch of them, not to mention squirrels, etc. Those are what we want to persist in the landscape. But unfortunately, at the height of the dry season, when forage is lacking, they start debarking these, and eventually they don't even have to ring bark them. We find that when you reach bottom right, 50% debarking, there's crown dieback, and it's more susceptible to wind throw. But bottom line is there's a slow attrition of your large trees, although you are maintaining canopy volume for elephants. A third quick example, this is the Chawanja Hills, a repeat photography of the last 11 years, which quite clearly shows, and it's similar for 175 photographs, a slow increase, and if you look at them, mainly shrubs, unpalatable to elephants, but also a slow attrition of trees. But prior to 2011, this area had been, on the hills that had been Brachystegia woodland, and on these sorts of things, more an acacia woodland. 3 spatio-temporal patterns of response shown in the map. So what is the net effect? One can anticipate refuges at greater than 15 kilometers. We have a few pockets of those, but unfortunately the configuration of the park is not such. And you then approach it in a different way. You ask a question, well, you know, why do elephants want to damage trees? And the answer is pretty obvious. They're doing it out of desperation because the actual energetic cost of harvesting bark is orders more than that of the feed stuff on the right. What they really want to eat is green grass. If you can look at the top panel on the left and look at what a bull there, look at the amount at the height of that in summer of green grass it can harvest per trunk load, a recent paper by Bruce Clegg, versus, well, one, interestingly, always more than breeding herds, which is obvious in terms of mass. But far more than the other components. It's more than double what bulls can harvest in terms of green leaves or green forbs or canopy bark. Energetically, green leaves and even mixed leaves are where it's at for a bull elephant. They would munch green leaves to their heart's content should they have the opportunity. The response of what they do to trees and that obviously depends on the attributes of the trees. So what I'm trying to say is, we approach this by trying to, in that paper bottom left back in the day, provide a conceptual construct of what is happening rather than just an empirical onslaught of measuring it. You know, I'm quite cynical about a lot of the papers I read. People measure stuff, and I mean, I do it myself all the time. You've got to get a living. You measure stuff, you get a story out of it, it sounds cool, but it is so much better when you have a hard and fast, and I'm not just talking some global paradigm. It's nauseating to hear intermediate disturbance hypothesis explaining just about everything out there in the world. I really think we need to bring our heads and thinking to bear on thinking why things are happening a lot more and having an a priori approach to this. Because when you actually ask that question, you say to yourself, where do bulls who inflict most of the damage want to be? And at the height of the dry season, a bull wants to be in a swamp. That's a picture of the reed beds on the top right at Chapinda before they got away. A picture of a nice large panhygrophilous grasslands also in Gonorrhea. The bottom one is the Sud Nile. Elephants, there's been these historical reports of the extent to which it's used, and it was great to see that it's still getting used. You go through the history, Maramau, Okavango, Struthers going up Zululand, the bulls in St. Lucia, Amboseli is well known for it. And the single best studied elephant story in Africa is Amboseli, a small system centered on a swamp, which accounts for a lot of its dynamics. The point about this is, if one takes this into account and you then look at the constellation of this Greater Limpopo area and you look at the problems besetting Kruger with elephant impact, the problems besetting Gonorrhea, to me, it is not a long jump to go to, well, if they could access wetlands, in which this case all lie in Mozambique, part of the problem is solved. And just to close, a quick contrast then with livestock areas. Here's my picture of Underberg area, that little patch of grassland. This is a dairy operation, but he runs a beef herd on that little thing. Now, you know, the only selection there is grass species, etc., classic sort of rangeland stuff. And we've got into this whole impact on diversity, and I will note, and I think Sindiso's talk following this will touch on this, I imagine, is we still stuck with just plant diversity in terms of livestock impacts. I haven't seen much progress into looking at consequent faunal impacts. So we're still at this very empirical stage. And yes, it is necessary. You have to do this kind of stuff to build up to conceptual. You know, it does take a while. I think they're getting there. Their recent paper tells me that they are getting there. And I'll close with the time perspective for a livestock operation. This is Neonetsi Ranch in Zim. Used to be reputedly the largest livestock operation in the Southern Hemisphere. This is a small remnant of it. It's only, you're looking at 2,300 square kilometers, yeah? The point is, it was started in the 1890s. It was heavily stocked initially. They've got there at least 80,000 head of cattle up until 1952. The point is, this wasn't fenced until after that, from the 70s onwards. And all the transactions went through headquarters, which is pretty much near that kink in the river, bottom kink, the middle river, the Mwanezi. And the analysis just clearly shows this historical footprint of incredible livestock pressure from what started well over a century ago, you know, 80, 90, what is that, 130 odd years now. The first 60 or so years put in place a legacy with which we still sit in terms of range degradation. And there's a corresponding sort of slide for bush encroachment. The point is, you come in now, managers, they don't know what to do about this, and they're all concerned because the manager hasn't been part of the history. They tend to associate this with management of the last decade. They miss the point, is that you don't reverse this overnight. Something that takes a century to build up is going to be difficult to reverse. In conclusion, I should have had the chance during some of these eclectic examples to push the point. I see a wealth of material there for what I see as the purpose of the GSSA's journal. Good, hard, honest work on local issues. If you've got high-flying stuff, obviously it's going to go overseas. But we need a quantum increase. From the exercises that I've illustrated there, particularly when one tried to model, it was astounding how poor the local knowledge base was. I see a need that we actually develop a more holistic systems approach where it's appropriate, in particular livestock production exercises on some of our more simple systems. I can't understand why it's never been there. I do put it down to the fact that we trained as empiricists. And I've tried to get into exploring what do we do about the more complex challenges. I dealt with biodiversity, carbon's no different. You know, any of these extra additional decision objectives we now had. And that's my final statement in sync with trying to relive my youth or recapture my youth, which is a failing objective, I might add.